Hello friends, myself R.D. Mahajan presenting my video on Laplace transform revision as exam point of view. First point, first shifting theorem. Statement is like this: if Laplace of f of t is f bar of s, then Laplace transform of f of t multiplied by e raised to at. Whenever that function is multiplied by e raised to at plus at or minus at, then it becomes a problem of first shifting theorem, and the result is replace s by s minus a if it is e raised to at is there, and if it is e raised to minus at is there, replace s by s plus a. Example, find Laplace transform of e raised to 3t into t raised to 3 by 2 plus e raised to minus t into sin t. Here there are two terms, t raised to 3 by 2 and sin t. Sin t is multiplied by e raised to minus t, that's why it is a problem of first shifting theorem, and this t raised to 3 by 2 is multiplied by e raised to 3t, and that's why it is a problem of first shifting theorem. And therefore we know that Laplace transform of t raised to 3 by 2, here power is not an integer quantity, and as per standard result its Laplace is gamma n plus 1, n is here 3 by 2 plus 1 divided by s raised to 3 by 2 plus 1, and therefore it is equals to gamma n plus 1. We know the result, gamma n plus 1 is as n gamma n. Applying till we get that gamma 1 by 2, and therefore this 3 by 2 plus 1 we can write down as 3 by 2 into 1 by 2 into gamma 1 by 2 whole divided by s raised to 5 by 2, and therefore it is equals to, this becomes 3 by 4. We know the value of gamma 1 by 2, standard result, it is root pi, and therefore into root pi divided by s raised to 5 by 2, and we call this as f bar of s. That is the Laplace of. Then applying first shifting theorem, Laplace transform of t raised to 3 by 2 into e raised to 3t. It is, as per theorem, f bar of, as it is plus a, we have to replace s by s minus a is here 3, and therefore substituting, replacing s by s minus 3, we get 3 by 4 root pi divided by s minus 3 raised to 5 by 2. We call this as equation 1. Laplace of sin at is a upon s square plus a square. A is here 1, and therefore it is 1 upon s square plus 1. We call this as f bar of s. Then applying first shifting theorem, we get Laplace transform of e raised to minus t into sin of t. As it is multiplied by e raised to minus at type of term, replace s by s minus s plus a is here 1. Therefore replacing s by s plus 1, we get that result as 1 upon s plus 1 whole square plus 1. We call this equation 2. And then therefore Laplace transform of this two terms, combination of two terms, e raised to 3t, t raised to 3 by 2 plus e raised to minus t sin t, as equation 1 plus equation 2. Equation 1 is 3 by 4 root pi divided by s minus 3 raised to 5 by 3 plus this equation 2, that equation 2 is 1 upon s plus 1 whole square plus 1 as the required answer. Go step by step to obtain the required. Second theorem is multiplication by t raised to n. If Laplace of f of t is f bar of s, then Laplace transform of f of t, that is multiplied by t raised to n, is obtained by minus 1 raised to n, nth derivative of f bar of s with respect to s. And therefore, try to solve the problem. Find Laplace transform of t square into sin t. Here sin t is multiplied by a term t square. Therefore, we have to apply this theorem. We know that Laplace of sin t as a upon s square plus a square. A is here 1, therefore 1 upon s square plus 1, and we call this as f bar of s, say. Then, applying this theorem, Laplace transform of t square into sin t, here n is 2, and therefore substituting n as 2 here, we get that Laplace has minus 1 raised to 2, and same order derivative, that is second order derivative of f bar of s, and therefore it is minus 1 square, that sign become plus a d, second order derivative we split as d by ds of d by ds of 1 upon s square plus 1, means we have to differentiate this term with respect to s twice, and therefore it is d by ds of derivative of 1 by x, standard result is minus 1 by x square. As per that, it is minus 1 upon s square plus 1 whole square, chain rule, as it is function of function, applying chain rule. Differentiation of s square is 2s, and therefore we get that term as minus d by ds of 2s whole divided by s square plus 1 whole square. Therefore, once again differentiating it with respect to s, it is equal to u by v quotient rule we have to apply for differentiation. Therefore, v is here s square plus 1 whole square into derivative of this with respect to s is 2, then minus u, that is 2s. Differentiation of this is 2 times s square plus 1, and into chain rule, derivative of this s square is 2s, and whole divided by v square, means it is s square plus 1 square and its square, it becomes raised to 4, and this is with minus sign. And then simplifying it, we can, and s square plus 1 common, we get that value as 2 times s square plus 1, we can take common. Remaining terms are, here s square plus 1 remains, therefore s square plus 1 minus, this is 2s into 2s, we get 4s square, and whole divided by s square plus 1 raised to 4, s square plus 1 raised to 4. And therefore it is 1 s square plus 1 2 times s square minus 4s square, we get minus 3s square. Therefore the term is 1 minus 3s square with minus sign, and divided by s square plus 1, that raised to 3. Multiplying by minus inside, we get 2 times 3s square minus 1 whole divided by s square plus 1 raised to 3 as answer, or that is the Laplace of given function t square sin t. Applying this result. Third theorem, division by t theorem. If Laplace of f of t is f bar of s, then Laplace transform of f of t divided by t. It is divided by t. It is given by or obtained by integral from s to infinity, or integration of f bar of s with respect to x between the limit s to infinity. Example, find Laplace of sin at by t. Hence, show that integration between 0 to infinity of sin t by t dt is pi by 2. And therefore, we know that Laplace of sin at as a upon s square plus a square. And we call this as f bar of s, say. And therefore, Laplace transform of sin at divided by t, as per this theorem, it is integration from s to infinity of f bar of s with respect to s. This is integration from s to infinity. F bar of s, we substitute that value as a upon s square plus a square, and its integration with respect to s. A we can take outside as it is constant term. Integration of s square plus a square, it is tan inverse of s by a, standard result, and divided by a, limit from s to infinity. A get cancelled, subtracting the upper and lower limit. For upper limit it becomes tan inverse of infinity minus tan inverse of, for lower limit it becomes s by a. We know the value of tan inverse of infinity, it is pi by 2 minus tan inverse of s by a. Again, standard result from trigonometry, pi by 2 minus tan inverse theta is cot inverse theta, therefore it becomes cot inverse of s by a. We call this as equation number 1. Result for the first part. Then using this result, we have to evaluate the value of this integral. Then to evaluate this integral between 0 to infinity of sin t by t dt, we try to convert in elementary definition or standard definition of Laplace transform. We multiply this sin t by t as e raised to minus st. With s is equal to 0, e raised to 0 we get 1. Therefore, we are not changing the value, we are changing only the form. And then as per definition, this is nothing but Laplace transform of that sin t by t. And then here in equation 1 we have obtained that Laplace of sin at by t as cot inverse s by a, and therefore as per that it becomes cot inverse of s by a is a 1, and then at s is equal to 0 it becomes cot inverse of 0, and the value of cot inverse of 0 is pi by 2. Hence we get this result. Laplace transform of a derivative statement is like this: if Laplace of f of t is f bar of s, then Laplace transform of a derivative of that f of t with respect to t, its Laplace is given by s f bar of s minus f of 0, value of that function at t is equals to 0. Example, find Laplace transform of d by dt of sin t by t. Laplace of d by dt of sin t by t is nothing but s f bar of s. F bar of s means Laplace transform of sin t by t and minus value of that function sin t by t at t is equals to 0. And we try to find out Laplace of sin t by t separately. Call this as equation 1. Therefore, performing the step, we know that the Laplace of sin t as a upon s square plus a square. A is here 1. Therefore, it is 1 upon s square plus 1. We call this as f bar of s. And therefore, Laplace transform of sin t by t, it is integration from s to infinity of f bar of s with respect to s. Just I have discussed this theorem. Then it is integration from s to infinity of 1 upon s square plus 1. Its integration with respect to s. Performing that integration, standard result, its integration is tan inverse of s by a is here 1, limit from s to infinity, subtracting the upper and lower limit, tan inverse of infinity minus tan inverse of s. Standard result, tan inverse of infinity is pi by 2 minus tan inverse of s. Again a standard result from trigonometry, pi by 2 minus tan inverse of s is cot inverse of s. And we call this as f bar of s. Say. Then we put that value here in equation 1. Therefore, it becomes substituting value of Laplace of sin t by t, whatever just I obtained, it is s into cot inverse of s into cot inverse of s minus limit of sin theta by theta as theta tends to 0. As per that standard result from limit, the value of sin t by t as t equals to 0, it is 1, and therefore we get that value for Laplace of d by dt of sin t by t as s cot inverse of s minus. Next theorem, Laplace transform of division by t theorem. Statement is like this: if Laplace of f of t is f bar of s, then Laplace transform of integration between 0 to t of f of t with respect to t as 1 by s into f bar of s. We have to multiply by that f bar of s by 1 by s. Example, find Laplace transform integration between 0 to t of sine of omega t plus alpha, where omega and alpha are constant terms with respect to t. And therefore, to obtain its Laplace, first of all we try to find Laplace of sine omega t plus alpha. For that, we have to first expand that sine omega t plus alpha as sin a plus b. Its expansion is sin a cos b plus cos a sin b, and therefore it becomes sin omega t into cos of alpha plus cos omega t or sin alpha into cos omega t sin a cos b plus cos a sin b. And then we take the Laplace on both sides, and therefore Laplace transform of sin of omega t plus alpha, nothing but the Laplace transform of right hand side term, it is sin omega t into cos alpha plus sin alpha into cos of omega t. Sin alpha and cos alpha are constant term, we take outside while finding the Laplace transform, and therefore it is cos alpha into Laplace transform of sin omega t plus sin alpha constant term Laplace transform of cos of omega t. Applying the standard result, Laplace of sin 80 and Laplace of cos 80, we get cos alpha. Laplace of sin 80 is a is here omega divided by a square plus a square omega square plus sin alpha. Laplace of cos 80 is s upon s square plus a square, and therefore it becomes s upon s square plus omega square, and we call this as a bar of SC. A Laplace transform of integration between 0 to t of sin omega t plus alpha, and its integration with respect to t as per this, it is 1 by s into a bar of s, and therefore it becomes one by s a bar of s, we substitute this value, therefore it is omega cos alpha plus s into sin alpha s square plus omega square, we can take as a common denominator or taking LCM. Therefore, this is the required answer or required value of that Laplace transform using this theorem. Therefore, in this first part, I have discussed 5 examples based on that 5 theorems. In next video, I will discuss second part for the revision of Laplace transform. If you like my video, please share it as well as subscribe to my channel and press the bell icon to receive the notification for my new videos. Thank you. Thanks for watching.